Hi. Go ahead, Mike.
Yeah, so first thing about the chassis, it's
You can also tell if anything.
Hey, Swafford, try and fix your mic real quick. It's kind of a bad sound.
In fact,
This
you're
must
muted right now.
Oh, now I'm muted?
Yeah.
stuff like that. So
Your audio's coming from my device.
Oh, and you're muted.
probably about twice as big as it honestly needs to be, but it just makes it easier for us to replace and stuff, especially since it's our first car. And also what's happening to the car from scratch.
No, I muted my laptop, so no sound comes out of it.
Last thing, just remember
That was closer. Brought it to my
that's not like
So
regular.
So it's okay.
At least someone can figure it out.
Yeah.
That's the goal. Right now,
Okay, right.
we'll get to that next slide. Go ahead and go to the next slide. Here, let's be right. If you have any questions, just go ahead and shout them out as we go.
Hey, Mike, can you maybe try and adjust your audio real quick?
Requirements. So we have four
I'm
key topics that we want to hit. So high strength, high torque,
She's in
I
it.
leave my Google voice on. You can manually control it, so it's always going. It's muted.
we can get to the like things out high strength. We're gonna after going to Iowa State, we had switched from using our SAE, I think 4130, the Chrome Molly. It kind of been this into the 1020 or 1040 series scale. It's easier to get, mostly from sponsors.
Can she see the
This is kind
power
of the biggest
point?
part of the chassis. The other thing is, we have a state champion on our team. Chrome Molly is inherently hard to weld, and you get distortion effects, and really we don't need to overcomplicate this thing, so we're just gonna stick to the basics. Next point on
Yeah,
there,
so everything's being recorded on my system, so it's whatever's on my system is what's video.
that kind of leads into the next part, which
And
is
if
our
you're
high
seeing it
torque.
on my video, then it's what everybody else is.
What do we want to, so the reason why we want high torsional rigidity is because that's really what the performance of a race car
The
comes
big
from.
issue is going to be the amount of
Space for your chassis.
bandwidth.
So really being able to
When he's on this
have
phone.
triangulation, like just extra stiffening rubbers we can have without overdoing it. It's really easy to overdo support and stuff like that. So that's kind of why we want to keep it in the floor near the main road. Why the suspension supports, just to keep the weight down, we put the strength and the really where we need them to get that extra bit of performance. Next is OCP. That really just kind of goes back to the top tier concentrating on stiff movement as we can on the lowest part, most shorter part of the car where we can do that. And then conservative use of the thicker materials. I know it's definitely something that I talked to the guys about, and they kind of, they just put the thick material in to have them. You pretty much use anything under an inch everywhere else they can. They can get around it, but still being able to add, it's different. Last part, just lightweight, just trying to keep the weight down because that also affects performance. Having both of the cars, no funding competition. So that's enough. You got any questions?
Oh,
Not yet.
Okay. All right. Yeah, go ahead and go to the next one here. All right. So this is the left side of the current chassis right now. So all the dimensions right now are millimeters, just because that's what's easiest to work with in Korea. It's really a pain in the butt to try and get things. It's empirical. back half of the car is pretty big. 775 millimeters, I think is about, I want to say it's about 30 inches or just under 30 inches. So that's pretty big for the car we're using and the battery size we're using. And like I said, it's probably about double this big that we actually need. Just going back. All the heights of everything are worked out.
Look up how to get rid of the status bar.
The 95th percentile male precision recording
Should be fine.
and the requirements for that. For the car is, yeah, you can go on another one, I guess. Alright. Okay, you want to go from the top? Okay, now go ahead and go back. Go ahead and go back.
This one?
So this shows the top, width of the car. So really the very front section is very front width is 401. So that's 401.
That's because he's on mute. David, you're on mute.
Direction
No, this computer's
that should fit.
Yeah, it's
This,
source of
this is going his.
Actually, computer.
and so it comes with the cords easier.
Just because we're way too close to competition to try and test and poke our own. And it's kind of a large undertaking to do that, so we're going to stay away.
We're using a physical
Total length of the car.
unit, so it's always recording.
You can't see it, I think it's 2,100 millimeters over south to 72 inches. And then the wheelbase is 66 inches. So I did some research on wheelbases. So I think a lot of the teams run around 60, or I didn't see any teams that run over 70. So we tried to kind of find that happy medium between a really short wheelbase, which would really restrict our kind of goal for having a large repair engine. Having to be able to fit batteries, motor, any other electronics, all that stuff back there. With the car, the driver's side width is very wide, which is good for the very back end. Unfortunately, a little bit, it's way more than we need in the front, but it's safer this way. That's a possible thing that we can look into is reducing the width in the very front, so keeping it as wide as possible as we can in the rear. Go ahead and go to the next one. This shows the front and the back of the car. So the front is on the label on the top. The front is on the left. That just again iterates pretty much all the main dimensions.
I mean, if he's in the car,
Mike, are you there?
Next slide has all the specs on it.
Hey, wait, Michael, repeat what you just said. You kind of cut out there a bit.
Now what?
Repeat what you just said. You kind of cut out there a bit.
Alright, Danny, you're gonna have to speak more clearly.
Repeat what you just said. You kind of cut out a bit.
I'm still not getting.
Oh.
I mean, he's naturally going to hit spotty reception areas.
Repeat what you just said. You broke up a little bit.
Oh, it did? Alright. Just for this page or for the last one?
What you were saying like a couple sentences ago.
I was just kind of just summarizing that this is just kind of reiterates points from the last page, just about overall dimensions, everything like that, just Ryan showed the consistency with the design. I think last time we reviewed this, probably through the rules was April 14th or 21st. After a couple of tweaks, it passes all the rules right now. The only thing about this chassis,
Oh man.
It's like Matrix sound.
Hey, wait, Michael, you're kind of breaking up a lot here.
Might be.
No.
It's
Yeah, that's fine. Why don't you just try and say that again real quick?
okay, yeah. For sure. We know that's I've been talking with wanted to optimize the suspension itself before being able to test and put it on. So if anything, the very manufacturer of your suspension is important into it or even like that. But really, I think we're gonna try and fix this to some of the Alright, okay. Alright, so this just shows all the spec sheet. There's the pictures of the car that I just showed. So version 1 is what we showed in the presentation here. So weight is 68 pounds, overall length is 84 inches of cams. Total height, and number 2 is for making sure the bill of sale sheet or that is 59. The CG, it's a little bit where that's where we want it. Given the our battery and driver, I'm absolutely sure that the final CG will be exactly where we want it. We're very close. So I'm not extremely worried about that. Version 2, so version 2 just has, I think it has the top front suspension and it has a sort of exterior on the bottom of
If he needs his video, is it going to be a better audio connection?
I think that's correct.
Possibly, but I have no idea. Because he has a fixed amount of bandwidth. If Hangouts is smart, but you just have to know what Hangouts chose to do. That is a decent amount of data, though. That would better be served to his audio.
Hey, Mike, real quick, can you try muting your video so that you can just get the audio? Because we're having a hard time hearing you.
Maybe better bit bandwidth.
Can you try muting your video and just having your audio? Because we're having a hard time hearing you.
Oh, shit. Let's see. Alright, turn the camera off. Alright. Yeah, I'm kind of done.
Actually, there we go.
Version 3 just has version just has a back end cut off. It's pretty similar to
There you go.
version 1.
You're going.
Just the other versions are just a test, like the car basically with different design. Yeah, that's
Yeah, so I guess I'll just ask one quick question real quick here. So in this picture right here, and correct me if I'm wrong, but is there supposed to be a bar right here for the impact attenuator to be mounted to, like a cross-sectional beam right here?
a crossbar right there.
Yeah.
Is that what you're talking about?
Yeah.
There can be, if it needs to happen, put that there. I'm not sure what you want it for.
In that front area, you have to have some sort of plate or fixture to have your impact attenuator on. So as it was,
That's
it's kind of counterintuitive because it's, yeah, you're gonna have your plate there.
Gotcha, okay.
Yep.
So I have some questions if you're done with your slides.
Yep. I can actually
Okay.
go through that. That's
Question in front of me, can you hear me? I just want to keep in mind the field test when it comes to ACV. When you first put together a full model of your Creo, make sure that you're putting in proper weight for your components, starting early so that it's not a huge task at the end. That'll help you calculate your ACV more accurately. You're going to have to take that. But you have a pretty good wheelbase that 60 into it, which will help you in terms of the field test. So if it doesn't have an issue, just keep it in mind.
okay.
Now, one question I have is that most of your model, and correct me if I'm wrong, goes down to, have you considered adding a square team member, as a mixture?
I have, yeah, we have, considered, just for the very bottom of the chassis. I'd seen that in a couple, that looked up online, and I think we have one of MIT's old version of the car.
Yeah.
And it uses, and we're totally open to that. It's more a matter of what we can get from whoever our, basically our supplier or sponsor is, for Speedo.
That makes sense. So one thing I learned in the brain is I did mine out of chromoly, so what you said about the difficulty of the world is totally true. But even if you have to buy the square tendon for like critical mounting bars, it makes a huge difference.
Yeah.
It also increases the technical rigidity, which you said you wanted a high rigidity. So it might benefit you if you can't buy the user. The next thing is that your front, if you back to the left side view slide,
Wait, what happened? There we go.
yeah, right here. So that bar that's triangulated to the top of your front view, that has to go all the way to the front impact structure. That sounds like it's moved there.
Oh, really?
Yeah, so if you look at the view, it's very confusing in the rules, and they would have caught this before you started building, because you have to submit your structural ability sheet.
Right, yeah.
But typically you have to, unless you have, the proper CAE, and they're really strict about it, to prove that it's okay at that node, you typically need to triangulate all the way to the front, so that in an impact case, the loads are being transferred back into the same front view.
Yeah. Okay.
Dave, this should give you a separate microphone.
One thing to keep in mind is the angle of your front hoop. I don't know what the rule is for electric specifically. At hybrid, it was 10
I think I'm
degrees.
still muted.
So as long as you're not.
Yeah, this is,
You have to do it
this
in your
is
terminal.
10 degrees.
Okay.
So,
Just be careful that in rounding, if you're right on the
No,
threshold.
it's
if
sharing my
you're
screen.
left,
Hold
you're
on.
rounding here.
It should be fine. I
Basically, that's your-
think so.
Similarly with your main hoop structure, I don't know the rules at weekend, but I think in hybrid it was 30 degrees, so as long as you're not violating that.
yeah. For structure, yeah, I think it's at like 40 or something like that right now. High 30s or 40s.
Okay, great. Last but not least, do you have your side impact structure dimension? Is that 250 millimeters?
Not quite. I think, yeah, David, move your mouse over.
Oh.
Oh gosh. Let's see.
Figure out what he wants
Yeah,
to
so the
highlight.
side impact, so there's a very top part that triangulates down to the main hoop. That one is not counted as a side impact. That has to be there for the height of the front roll loop. It's only the bottom one, the triangulation going from the bottom of the front roll loop back to the main roll loop, and then the horizontal one again. Those are the ones that.
Yeah, so just make sure that we measure that. It's actually from the ground up, so it's not from your
it's from the
bottom to
ground.
Okay,
Yep.
all right.
I
Just want to
think
make sure
right
you're
now-
considering rising.
Yeah, it's at 332 right now, and the rule's really weird how it says between 300 and 350. So I
Yeah.
think that's why we tried to put it as close to 350 as possible, because we're not sure what the ride height's gonna be yet.
Okay, yeah. I think they give you that leeway because that would be your 2 inches of ride height travel in jounce and rebound.
Yeah.
So
Yeah.
just keep in mind, because ride height gets crazy when you actually go to build. It works in the
Right.
CAD model.
Yeah.
Just keep it in mind, the bid our team our first year. So I'd be interested to go through with you once you have kind of your model a little more refined and talk about a plan to analyze your torsional rigidity in a computer modeling system, just so that you ensure that you're stiff enough before you go to make it and that you're still meeting your weight goals in addition to that. So we can talk about that. I've done it in SolidWorks many, many times, so I have the process down. We would just have to, I think you're better at Creo, so maybe you could learn a little bit about the process if you need help with it and then apply that into Creo. Because the nodes are really tricky in CAE analysis because all that welding has to be done properly. So
Yeah.
we'll cross that bridge when we come to it. But this is a really great first model. I think it's really cool that you're doing multiple versions to analyze your pros and cons.
Yeah.
My last question is do you have like a list of rules that pertain to your chassis that you're using as like a checklist?
Yeah, it's really long. We have a chassis rules folder, Google Drive, and it's probably 8 pages.
Yeah, here, I can pull it up real quick.
It's a lot.
We can go.
Yeah, if you can pull it up, that'd be great.
Yeah. Yeah, so actually we had all of our teams do this. We had them go through the rules and just skim through and then also jot down some important rules that they thought would be really critical and really important to know for when we do design and eventually build. So let's see here, be in here, in here. Whoops, no. Research.
Yeah, it's in research. Yep.
Is it going to be this one?
Yep.
Yeah.
Yep.
Great.
Yeah, so you can see it's 18 pages long. It's got a lot of detail in there.
Right, yep, this is great. So when you do have your final design done, if you would like, we could go through these, and I can act as a judge and just make sure that you're meeting it, or I can review your SDS before you submit it to catch any.
That would be fantastic.
Okay. I've submitted a few back in my day. Might be able to help catch any errors before you submit, because it takes them forever to get it back to you.
Yeah, I can understand that too.
Okay, great, but this is a really great first start. I think you've considered a lot of things and you have really good design decisions behind what you're doing.
Okay. Sweet.
Okay, fantastic. So try again.
Hello?
Hi.
Hi. All right, so you can hear us fine?
Yep.
All right. So I'm Walker, suspension sub-team member. So,
Yeah.
what was that, Pass?
I was saying that I didn't save, so I changed the output, didn't save. It was actually sourcing from my computer microphone the entire time. Maura, can you hear me?
Yes, I can hear you.
Okay, so everybody in the room, if you speak loud enough, you can hear. You just have to speak radially into the microphone. So that was, yeah. We had a little bit of a technical difficulty. We have a microphone in here for like the entire room to speak into, but I didn't change my input, so we're good. All right.
Okay, great. So we'll get on with the suspension. So we're going with a double A-arm design. It's very commonly used design, so it should be easy to find components available for purchase, so we don't have to design every single component. It will allow for ease of adjustment, and it will be easily optimized to be able to save weight. So here's kind of the preliminary designs. We have our half shaft in with a hub, upright, and brake rotor, and all that fits into a rim. And so the upright is the only custom design piece here. We're missing a slide, but basically what it said was kind of there are two kind of designs for the control arm.
Pull it up.
Oh yeah, we can probably pull it up
Yeah,
here.
here.
I can pull it up on mine.
So, yeah, that extra slide, sorry about that.
The only downside. The only downside is the recording is actually switched
Alrighty.
from Yeti. So
There
actually,
you go.
would have picked up
Yeah.
everything just fine. The only issue was the transmission. So yeah, I mean, that's fine. We're good. We've been good for our record.
All right, can we full screen this?
Um,
All right, perfect.
here you go with that.
Cool. All right. So I did some research on control arm designs, and I found two main designs we could go with. One was the using rod ends in the ends of the control arm. Now this allows for very easy adjustments to be made. However, there's some downsides. There's a stress concentration at the rod end, and also because the line of action between the two mounting points is not the same as where the actual member lies. There's additional bending stress at the rod end, and so for these reasons, this design is highly scrutinized in the judging process in competition. Also, the design is inherently heavier than a one-piece control arm. So about a month ago, we toured the Iowa State team's facility, and I took a couple of pictures of their suspension. So as you can see, they're using kind of a one-piece control arm with spherical bearings at the mounting points. And so this design should be inherently stronger and lighter than the one using rod ends. So the only downside is that adjusting it is going to be a little bit harder, but all you have to do is put in shims, and you can see in that right picture, that's what they did. So to show good engineering practice to the judges, I think that this one-piece control arm would be the design to go with.
Yeah, I'll tell you from experience. I went with a spool bearing my first year, and although it is difficult and the shims are a pain in the butt, the judges definitely are more receptive to it, because this year that team went to a rod end usage. It ended up being really heavy, and they had to add a lot of reinforcement because they found bending and issues during tests. So spherical bearings, although difficult and come with challenges, are probably the better option.
Okay, yep. Moving on. All right, so we have a basic parts list here. So there's only like 4 parts right now that we're actually manufacturing ourselves, and that would be the uprights, control arms, push rods, and mounting brackets. And of the parts that we're purchasing, the dampers are going to be by far the most expensive at about $600 a piece. So hopefully we can get our funding squared away for that. All right, so what we have left are a few things. So basically, the next step for suspension is going to be to obtain the Optimum K software and use it to determine our geometry for the control arms, push rods, and whatnot. So, and also, we need to design our mounting brackets for shocks and control arms, and work with the drivetrain team and hopefully with Optimum K as well to determine an optimal half shaft length. And also we need to find a company to machine all these parts for us.
Okay. So are you planning to use an inboard like shock and damper, or are you going to put it outboard in line with your push rod?
Ooh,
I think Greg was talking about having a rocker.
a rocker?
Yeah.
Is that kind of what Iowa State used?
Yeah. Yeah, so I imagine it would be outboard.
Inboard?
Or, yeah, sorry,
Okay.
inboard.
Inboard?
Yeah, inboard with a rocker.
Okay.
Okay, good. So one thing to consider is that you do have a variable motion ratio when you do a rocker arm. So keep that in mind when you use Optimum K, that you do have a lot of adjustability with the inboard suspension system.
Okay.
Are you planning to do an anti-roll bar system? Or
Ooh.
for this year, are you just going independent suspension?
Probably independent for this year.
Okay, fair choice. We did the same. Most teams, like really good teams, have anti-roll bars, so that's something to work towards and look into, but you definitely don't need it this year.
Okay.
In terms of your springs and your dampers, are you planning to get variable spring rates so that you can change on the fly, or do you only have the budget for one spring?
Oh, yeah, that would depend on our budget a lot.
Okay.
I guess right now, maybe just one spring.
Okay, so in that case, I'm glad you chose inboard, because then you have the, you can kind of trade off travel for spring rate if you only
Okay.
have one spring, because you can change that motion ratio. So, when you get there and you need any help calculating the motion ratios because of the complex geometry problem, let me know. There is a really good site, and I don't know it off the top of my head, but if you're just looking to understand suspension parameters and what changes what, because you said you're still determining control arm size and length.
Yes.
And Chassis said they have their wheelbase figured out, so there's this little program that shows you a 2D view of the suspension, and you can change your rim size, your uprights, your kingpin angles, any parameter.
Okay.
And in 2D, you can kind of see how that would change your roll center and your pitch center
Mhm.
to help get a good starting point for Optimum K. 'Cause
Okay.
Optimum K is quite a big piece of software, so when you bring it into 3D, it helps to have some 2D dimensions figured out. So I'll take that as an action item and provide you the site if
Okay,
if you
great.
think that would be helpful.
Yeah, we'd love it.
Okay, great. Other than that, do you have any engineering requirements that you're looking to target for your vehicle dynamics specifications?
Oh, we can look at the rules from the FSAE, but as far as like personal goals, not much yet.
Really just to make something that'll work and perform to the minimum standards.
Yeah.
Okay, so you're kind of going for an average
Yeah, definitely.
average type suspension system?
Yeah,
So
I-
one thing I would encourage, so your chassis lead said that you were gonna go with a really high torsional stiffness, which means that, in terms of suspension, that you can make the assumption that your chassis isn't gonna put any extra play into your system.
Okay.
I would challenge you to come up with some engineering requirements, like where you want your roll center to be, what you want your
Sure.
kingpin angle to be. If I'm saying something you don't understand, let me know, I can try to explain it. What you want your camber and caster angles to be, because that'll
Okay.
help you format things and get a really good starting model in Optimum K. Because like I said, it can be pretty daunting.
Mhm.
But the 2D suspension website can help you determine those values based on your rim size and your wheelbase and what you're going for. If you're going for an average car, then you can kind of design to the nominal.
Okay. And what was that website called again?
I gotta go back and look at it.
Oh,
I'll
okay,
email it to
right.
David. And then he can pass it on to you. I'll do that right after this.
Okay.
There's a book. It's really cheap. It's by Carol Smith. If you haven't read it, it's called Tune to Win. And it's like a really high level suspension book that helps determine why you would choose suspension values and kind of what's average if you're just going for average. He was a professional race car driver, so I can also send along that book recommendation if you're interested.
Okay. I believe our suspension lead has that book right now.
Yeah, we actually already have that.
That one's a
Sweet.
good book to go by. There's actually, I know it sounds cheesy, but in the back of the book, there's a cutout suspension system, and you can move it around in real life with paper. I found
Oh,
that to be
neat.
pretty fun.
Yeah. Well, I'll definitely have to
Also-
take a look at that one.
Okay, I think you have a good starting understanding and you're in the right direction with the double A arms. We're getting some engineering requirements down. Would be really helpful to help you and the chassis lead determine some vehicle dynamics parameters because you're so intertwined.
Right. Definitely. We'll have to work with the chassis more on this one.
Sounds good.
Okay. Thank you so much.
Now, I did have kind of two quick questions. As far as the uprights, when we originally started to research into the suspension, we didn't find really like a standard upright design or a standard upright to buy, so we went on with designing our own. Is that a safe way to go about it? And if so, what kind of requirements are we looking for in order to get that machined properly?
Good question. So most teams make their own. That's probably why you don't find a lot out there. If you were looking to buy some, Polaris is really the only good supplier that will fit in your rim because they do ATV uprights.
Right.
Mhm.
And they actually do donate. So if you contact them early, you can get rod ends and uprights for a donation. So they will do that. I do have a contact if you want to reach out.
Yeah, that would be
That's
fantastic.
one option, which I can send you as well. Let me write that down. Okay, that's one option. Another option is to design your own, which is what most teams do. If you're gonna CNC it out at a design CNC, a professional CNC shop, I should say, you can be a little more crazy with your design. You can do intricate cutouts. You can have angles. If you're gonna do it in-house, think about the milling process and how many setups do you have to do to achieve those angles.
Sure.
Is it worth you up 2 grams for an extra 5-hour setup? So
Right.
things like that come into play. When you design your upright, be sure that you're completely understanding the steering geometry because that's a huge part of the upright. So where does it need to be on the upright? Does it fit within the rim, etc.? And make sure that they're mirrored images of each other. So when you send it to the CNC, don't ask for a quantity of 2. You're gonna have to mirror that one because we did that our first year and we ran into huge issues.
Oh,
'Cause,
wow.
they should be mirrored pictures of each other.
Right.
So we're too wide. Don't do that. So a lot of things come into play, and again, your kingpin angle is going to be a huge part of your upright design. You guys know what a kingpin angle is before I keep talking about it?
No.
You know, I've read about it in a book, but I haven't memorized it yet.
That's fine. So the kingpin angle in a control arm suspension, you have your upper and your lower point. So when you draw an angle between those 2 points to the ground, it's going to either be straight up and down, it's going to be tilted, it's going to change the angle. Where that line crosses with the contact patch of the tire is called your scrub radius.
That's right, yeah.
Important for you because you're not allowed to have a power steering system. So the more center your scrub radius is, the easier to turn the wheel is for the driver.
Right.
However, there are benefits of being slightly off-center or really off-center in terms of vehicle dynamics performance. So that's something to look into and consider as you go through it. Having a kingpin angle straight up and down is easier to design because you don't have any fancy geometry. So those are all things to take into consideration with your uprights, but it's doable as a first-year team to design them on your own and get them milled, or you could go the Polaris option, although it will give you some constraints in suspension design because that's a set A to B point for your outboard points. So just some things to consider.
Okay.
Okay, awesome. And then, I think we pretty much covered control arm design, right?
Yeah.
Yeah, okay, so yeah, then never mind, we did that. Okay, cool. Any last thoughts or anything?
All right. I think that pretty much covers it.
Okay, awesome. Thanks, Walker.
Yeah. Thank you.
Alrighty. Pass
Yeah,
one.
let me know.
You want to go ahead and take it next?
Yeah, sure.
right, cool.
For that, let me share my screen. Maura, can you hear me all that well?
Yep.
Awesome. Let me just go and select that and see the, there we go. So if you come in on my screen, we should be good. So as far as the presentation, Ryan, are you there?
Yeah.
Awesome. Can you hear Ryan, Maura?
Yep.
Okay. Awesome. You might want to hold him up.
Yeah.
Be his legs. Okay, so we'll kind of be just going intermittently, so I've got a few slides.
Yeah, so this is electronics.
Yeah,
You
this
might
is
say-
electronics. So we are unfortunately the least developed out of the teams in terms of having, it took quite some time to research the vast number of different kind of components and systems that we were going to be working with, but I'll just get right into it. So we'll go over design intent and purpose as far as what the team does, engineering requirements. That's a little bit sketchy, but I've got the 27 pages of regulations condensed into a single PDF, and we've been reading them religiously over the past semester, but I can kind of just go over the basics. And then systems overview as far as what we're working with, it's probably just review, from what you saw, nothing too novel. And then as far as more relevant, we've got current progress, challenges that we have, and what we're looking to do, immediately. So just simply.
PowerPoint, are you?
Oh, you're not sharing the screen.
Oh, sorry about that.
Oh, you're good.
There you go.
Okay.
Yeah.
I can get her.
Wonderful. So, just again, what we'll be talking about: design intent and purposes, engineering requirements, systems overview, current progress, current challenges, and what we're going to be doing. So, we are just doing. We're handling all of the electrical systems. So everything from the battery system, or the what's referred to as the tractive system. We're just powering the motor and handling all the user controls. Anything that is, has amperage going through it, we're going to be working with. And we also are implementing the team's high voltage and electrical safety policies, which will be fairly significant given the nature of the project. As far as engineering requirements, we're mostly just trying to have everything be performing at the minimum that it needs to be for competition and meeting compliance. So just making sure that we're actually powering the motor, that the car shuts off safely, from the litany of different kind of shut-off circuits and shut-off conditions, either from the user or from, malfunction. Make sure that the battery management system is safe. And, that's kind of the biggest kind of safety concern that we have right now, is just not having somebody, be maimed in a terrible hellscape fire from, not doing battery management appropriately. And I think Ryan probably can talk about systems overview, but we have everything broken down into two. Actually, he can.
Yeah, so Ryan, we're on the systems overview PowerPoint slide right now.
Okay. So it's basically, we just kind of made a general map of what the whole thing will eventually kind of look like, and kind of take it step by step, and implement each part. Some parts are missing, just because we aren't fully sure exactly how everything's all going to work together, but as of right now, this is kind of our best understanding of how things will work, and how things are kind of connected, and what the general flow of the whole system is.
The only thing that might be a little different here from what I read is the overall kind of control system of the. Let's see if actually I can just pull it up real quick. And there we go. And let's change the. Okay, got a little Khan Academies type thing going on here. So the overall design, I'm going to do tractives, that. So the GLV is going to kind of boot start the tractive system. Look at how terrible that is. But as far as the AIRs, the accumulator isolation relays, that's the whole system. The grounded low voltage is when everything's off, the entire thing's off, but then the first thing that gets turned on is the GLV, then that activates the tractive system, and then that activates the motor controller, and then that activates the motor, ultimately, assuming through the ECU. So that's the overall.
So, ECU, are you referring to engine control unit?
Are we, sorry, what was that? Oh, what was that again?
What does ECU stand for?
Yep, sorry. So there is an absolute plethora of initialisms, and that was a bit of a difficulty in parsing through the rules. So the ECU is the electronics control unit, so it's just the main microcontroller, I guess, the main brain. There are a few different microcontrollers that you use, and some other more sophisticated teams are using them for taking kind of preliminary measurements for things like torque vectoring and whatnot, or they'll pass off functions, they'll split it into little subunits, so that way they don't have to have everything dependent in one giant microcontroller. But ultimately, in terms of the executive decisions that are made, it all goes into the ECU, which actually that's probably on low voltage as far as a control, but it's pretty easy to, with transistors, to step up low voltage kind of controls for larger systems, as long as you're using the right separations, and as long as everything's galvanically isolated. As far as the GLV, there's full galvanic isolation between the two, but just as a crudest of drawings, just so that we're all kind of on the same page. And then and then motor, and then the batteries are, the batteries are kind of connected when the tracking system kind of engages, or when this, probably actually right here. So anyway, it's all kind of reflected here. This is the only difference I saw, is maybe that wasn't maybe reflected in this, as far as the whole master system, or the master control, is low voltage, and then that bootstraps, if you will, on a power kind of level, the high voltage, and then they're kind of intimately intertwined. But all of the controls, all the sensors are low voltage for the most part, except for you've got the tractive system active light, but that's just using the high voltage at the battery level to just have status LED lights for each of the accumulator segments. And as far as so I can explain the system, but it's just a bit convoluted, and we're just starting design right now. One
question before we walk through.
Yep.
You said your T-cell is high voltage. Are you going to use a DC converter to set that down to that level?
The regulations stated that so I was just going to use a high impedance path out, but then again, I was having to think about how you'd actually accomplish galvanic isolation, because you can't use the same ground between the two systems. So actually, the tractive system active light is going to have to be entirely on the high volt side. And I was just going to use a really, really high impedance path that allows enough current to power whatever LED or whatever kind of indicator light that we're using. But the current is ultimately being sourced, just not a whole lot of it, off of that high voltage line. You just have to make sure that it's entirely, that there's enough insulation, that it's not getting anywhere near close to anything that's going to come into contact with the driver, that you're ultimately getting the light output from it. But that's, so if there's current, if the battery's getting connected, and actually Ryan had it right there with the AIRs are getting, and tractor system management system. There's a whole bunch of different things which ultimately power the thing on, and different stages of control in it. And it's a little bit, we don't have concrete schematics down that we'd like. We're just starting to get those down, and they'll kind of come through the next week as we just actually kind of settled on the tools that we're using. But did I answer your question?
In our case, we used a DC-DC converter because we were able to get the clearance requirement that we were required to have between high voltage and that light. So I was just wondering why it was in orange. So it won't be part of your low voltage, but you're saying it will be dropped down somehow in voltage so that it's...
Actually, no, I said that it, so I saw a particular part of the electronics rules that I almost thought, that's what I wanted to do, but then I saw a piece of the rules and I could just be reading it incorrectly, that almost said you could not do that, must include, let's see, here it is, it's EV must be controlled directly by the voltage present within the tractive system. Although it says controlled, it doesn't mean powered. So there you go.
That's just meaning that you can have software. So you could have, if you have 60 volts on this side of the circuit, you could have a DC-DC converter to power it down to like a 12 volt LED. Because having a high voltage light is
really
number
dangerous.
one, it's going to drain your power, and number two, it's pretty unsafe.
Yeah,
so,
the safety was the
people use DC converter, but I have a friend on the rules committee, so if you would like me to ask him, I can confirm.
No, actually, I think it's after reading it again, it says controlled, which doesn't mean powered.
Why don't we ask him anyway? That would be really nice of you.
Okay, I'm pretty sure you can use a DC-DC, but we
Okay.
will,
No, you can,
we'll just
because
confirm.
that would
Be great.
So I just, when I read it, that one time. Anyway, it just said so. I got thrown off by software control, but that it's still within the it's still being controlled by the circuitry if you use a DC-DC. It's just, in fact, you achieve galvanic isolation just by using different transformers, and then you just have to make sure, and actually there's no need to really regulate it at that point because it's just a light, so there's not any,
Right.
it can be kind of low level and doesn't have to be the absolute most efficient. The drainage or the power or the parasitic, drainage of powering it off the low voltage wasn't the issue as long as you have a high enough impedance. That's limiting the amount of current that's draining into that light. But in fact, if you're draining too much
Right.
current, you'll see it and it'll heat up way too much. But it was just having those two lines out there was the issue, or having that node in the design, which wasn't ideal. Anyway, that's good for that. And then as far as, so that's just the overview, and that's where we're kind of starting, and we're just piecing together the workflow that we're going to have over the summer. We're looking to have working final designs. They might be rough draft into as far as where they end up by competition, relatively speaking, but something that works, something that we can build or at least order parts for by August 10th. We've just gotten the regulations complete for the most part, although that little bit there would show that there are possibly some ambiguities in interpretation that just have to be ironed out. But I was kind of thinking, when you sit down and start actually piecing together these circuits, that it becomes fairly obvious, what they mean. It's a little bit hard going through 27 pages, but we've gotten initial research, and we've been extremely fortunate to find what amount to instruction manuals on how to do what we're doing. So Wisconsin Racing, for example, has their entire everything that they did. Down, and so this is a master's thesis paper from Portland State, and it's from an electrical engineer, and he basically it's heavy in the electrical engineering side of it, but he just basically made a made a manual on every kind of difficulty that they experience. So I won't spend any more time on that. Anyway, we have an electrical safety advisor. We need to establish a little bit more of a rapport with him. We're going to start beginning electrical safety training over the summer. We're kind of limited right now in that we have 3 team members. And so in order to make sure that we have an ESO on site for charging for any work that we're gonna have to do on site during competition, we're gonna have to, at this point, have everybody be trained in it and registered. We do have some concrete parts that we've basically settled on. The MRAX 228 was fairly popular. The motor controller that most people seem to use was the Bama car. We've just kind of started coming together as far as setting deadlines, setting work for Asana and Slack. We have CAD software picked out in Eagle. It's free for 3 years or so for near professional use. And then as far as actually making sure that we have enough for both power and energy for the entire competition, making sure that we can do well for acceleration and endurance. We found software called Optimum Lap, which I think quite a few teams use. It's basically the motor. We need to do a little bit more research over all the details for AC brushless motors. This is a 3-phase, and we need to have all the details down for like heat management and cooling for what we're going to need for both the controller and the motor itself. But we've got some extremely good resources at the moment, and this is a little bit of the Wisconsin Racing. So they just have all of their schematics for everything that they did for their electronics team up online. So any kind of big questions we have as far as actual construction, we can kind of turn to there over the process. The challenges that we face for the team are that just what we're doing in terms of the different number of components are fairly vast. It took quite some time to digest through the rules, and we are also responsible for tons of mission critical components, although that can probably be said of everybody else on the team. But if something major isn't working in electronics, such as the battery system, then it bottlenecks production for the entire team, and there's a huge safety consideration. We also, there's a lot of new frontiers for, the 3 members that we have in terms of the different kinds of things that we'll be working with. But I think that can be overcome. We do have a lot of skill sets already, but there's just a lot of new stuff that we have. And we have limited manpower at the moment. We'll probably work around that in some ways when we start recruiting in the fall when students get back here on campus. Once we have something tangible and once we have a workshop that we're doing and that we can show off as a kind of recruiting tool, it'll be easier to get more people that can handle, ideally like sophomores or juniors that can just handle some of the sensors or that we're going to be designing. And we have a limited amount of time to do a relatively high amount of work, so task management. And what we're doing immediately next is just going through and looking at every single component that we're going to have to be designing, start writing some details about it, start going from these abstract models to something concrete and putting it all on a timeline. The timeline's going to change change during production, but just having, knowing how are we standing so far as what needs to be done and what are we doing, and then delegating tasks to individual members. And next, by Saturday, we're looking to actually just start drafting component schematics and actually start work in earnest. And so we don't have a whole lot to, we're gonna start by taking easy, low-hanging fruits such as the ready-to-drive soundboard. I've been doing Arduino projects for years upon years now, and so just building stuff that we already know how to build so we have some confidence and then at the same time tackling the larger systems and just making steady progress over those. But each week just pick something that can be done in the afternoon and make sure that 2 or 3 of those projects are being done, 2 or 3 of those components are being done, and make sure that tangible concrete progress is being made on each of the major systems that we have. So that's where we stand. It's just a lot of work to be done, and I think that we have the ability to get a tremendous amount done over the summer given the schedules that we have, but that's where we stand at the moment.
Is that 3 including Samir?
Yeah.
Okay.
So.
All right. So I have some questions if you're ready for them.
Yep.
Okay, so MRX 220 and the BAMO car controller, do you have a BMS picked out?
No, but I know
No, not yet.
I've been doing research over just lithium-ion battery accumulator-based systems or accumulator systems, and I know what they need to be doing. I just need to, I'm not sure to what extent, I assume that we'll purchase the system and just make sure that this is a fairly common need as far as using these large lithium segments, lithium-ion segments, and just making sure all of the that the load balancing is being done, and that make sure that we have the right temperature sensors, and that's being shut off, and that all the feedbacks are correct as far as the isolation relays, that those are getting actuated appropriately when the system is unstable.
So do you have accumulators picked out yet, or are you still looking at what type and supplier you're going for?
For the accumulator, we were just just on the same page. My understanding was that the accumulator is just the term accumulator is used because you could be using a solar car, so you could have both batteries that are storing what you have, and then also sourcing new current onto it or new, and so the whole system combined. But because we're just doing nothing, so we're just charging the thing. We're taking the battery out, charging it on a cart, and then placing it in and hooking it up into an existing infrastructure. So we're not.
Okay, so you're
Yep.
but you don't know what kind of accumulator is used because people use supercapacitors as well. So it could be a battery or a supercap, and it can be used all over the
Well,
place.
what were the ones that Ryan found? Was it Ryan or Samir? I think it was Ryan, the similar ones that Wisconsin uses, those modules.
Those are.
Yeah.
I can pull those up, but I was thinking, is there any reason that we couldn't use a mixture of the two? Given so the batteries and supercaps have different kind of advantages. The supercapacitors are really good at sourcing current real quick. However, as soon as you start drawing current from a supercapacitor, the voltage starts dropping, whereas because a battery relies on a chemical store that you're constantly depleting, you have a constant voltage, and so what you use the lithium-ion batteries to be the backbone, so to speak, or the big reservoir of energy, but then in terms of short power, so that you're not, the problem with batteries is that they tend to have a fairly high ESR, so if you draw a lot of current from them, they only have a certain chemical reaction capacity, and so that the effective voltage drops, and so to make sure that you can source current really quickly, use the capacitors, but then if you need it for just the long haul, use the battery.
Right.
However, that adds to the complexity of the battery management system because it's an entirely other component. If our needs are being met and we're not going for breaking any records or anything like that, we're going to start with the absolute basics. Like I'm not sure if we could build the system entirely just off of supercapacitors alone.
Yeah.
But those are a finishing touch, and that any race competition vehicle is necessarily going to have them.
Mm-hmm.
But I just wanted right now we just hadn't done too much work on that because we were thinking that we were going to start with lithium-ion segments. Wisconsin, let me see if I can, and that's Wisconsin Racing. Let's see, Formula FSAE.
Yeah, I think it'd probably be easiest to go with just one type of electrical power instead of two.
Well,
Just to
the
keep it
two,
simpler.
it's not. It's not
I was
that.
just making sure that was the plan.
Oh, yeah, okay.
They use supercaps and hybrid a lot because you have the engine to regenerate.
Right,
So
that makes sense.
Yep, and that's.
it's advantageous.
Well, actually, we might be exploring regenerative braking because I do believe that the motor controller can handle it. That's one of the areas that we are absolutely least familiar with. It's something that everybody's excited about, like, oh, regenerative braking, that's the future. Why would you waste that electricity? Well, it probably requires some sophistication that we don't have right now, and that seems like a feature that we're only gonna. And I know it's a giant design core feature, in that you're almost gonna have to start from scratch if you do it over again. But again, our objective is to this summer be racing.
Right.
It might be the laughing stock, but if you can actually complete courses and not be disqualified, that is what I define personally as success for us at this point.
Yeah, definitely.
Given that this is literally generation numero uno for all of our Formula team. But once you have that car and when it's up, people are like, damn, that's it. Like, who wants just go into the College of Engineering, like for freshman sophomores, who wants to build a race car? And you've got a car to show up in the engineering student commons.
Mm-hmm.
So,
I agree. I've been there before. So I'm
oh, here we go. I got it.
So my question, all those questions were kind of leading. So you have the motor picked out, so you know what kind of what current you need to draw based on how you want the torque of the motor to behave.
And over
I guess, have you had any discussions with the drivetrain in terms of what current you want to pull, what your target C rate is, and then my electrical expert who's listening over here just pointed out that you have to know your configuration of your batteries in terms of series and parallel to understand and pick a BMS, because that's a huge part of the BMS.
Yeah,
so
absolutely.
That was just some questions I had. I wasn't sure if you had that mapped out, as well as the ground low voltage and tractive system diagram you showed.
Yeah,
That's another huge area. That
so
is,
I've got that
the
up.
spec.
I've got that up right on my screen here. Is everything I've seen has just been 1S8. So one as far as the core unit. I'm not sure how they arrange these for for an actual segment. Actually, you'd have to. I think. But they take these as core units and then build them up in ways. I know that the rules stipulated that once you hit, I think it was 6 megajoules worth of total energy storage, which I think was like 170 batteries, you have to branch off into a new segment and then physically wall them off within the accumulator container. But those were kind of I do apologize for not having anything more for you to sink your teeth into. But
Don't apologize. It's fine. This was just where you're at now, and if you need help.
Yeah. No, we definitely can, but it's probably at a point where we just have to start physically getting some stuff on the drawing board. We've just been looking and figuring out what needs to be on the drawing board and not actually making like real designs. But it's just going to be sitting down day to day and just making sure that we have the process to make sure that the work is being done in the timeline that it needs to be. My biggest kind of concern for actually producing on time is just underestimating complexities. But this is why I'm grateful that we have what are effectively 2 manuals on how to do what we're looking to do, and you know, your consultation on anything that we're getting absolutely just twisted, you know, having our arms twisted over on. But you know, we are aware of, we're just kind of the big details, but none of the specifics which are invariably going to come up.
So are you looking at the images packs? Is that what your main target is right now, or are you still looking at all sorts of packs?
We've kind of gravitated, huh?
Sorry, go ahead.
We've gravitated towards just using lithium-ion packs that are based on everything that so the first thing that I very naively looked at, so I was just, in fact, it was before I joined the team, I saw some guy that took recycled Tesla, like Model S, you know, they've got the giant, they'll have like 40 of these things in a car, but it's like a giant array or grid. But those subunits that they had, it had a lot of nice features, and it apparently had really good power density, and weight is always something that we're looking to cut down on, but it seemed like there was a way more parallel distribution, sourcing for sourcing way more current than we were ever going to need. It was everything, and they were just planning that we would take these like in, you know, stack them in series or in parallel to whatever, you know, extent that we needed to get whatever voltage, whatever current we needed to source. But yeah, we kind of have a good idea as far as the actual battery technology, the core battery technology, but we need to take that and actually build a prototype system. And there are a couple of accumulator designs I've seen, and there's actually good, you know, literature. So it's just an issue of
yeah, so I would just consider the versus pouch and how you want to fuse based on your series and parallel number of cells. So that's something to sit down and figure out. And then I saw this page referenced Orion BMS a little bit down. That's a very commonly used BMS, and it's pretty easy to program for beginners. So if you can afford an Orion BMS and you have the correct configuration to package it, very good BMS. So if that works with the system you're looking at, then that's even better. Because those packs you're looking at, you also have to consider that you have to mount thermistors on X amount of cells throughout your pack to monitor the thermal aspect of the battery to ensure you're not overheating and causing a thermal event in the driver.
Sure. That's
so
all.
Keep that in mind. That
is that all?
And you have the bus bars that you were showing me. That would be a good place to mount the thermistors.
Yep. Because it's not well, and then just run current through the bus bars on. Let's see.
Yep. And I think it has internal fusing, which is also nice if it's already fused.
Mm-hmm.
That will give you a lot of hassle in the end, because adding in your own fusing is a pain.
Yeah, I'm sure.
But I think you're on a good start. I think the next step is definitely to understand what kind of current you want to pull based on what you want the motor to do and what torque you want to output. And then just determine, get some things down and then look at schematics. So if you want to have a date to review the schematics, I can try to get my group friend and we can sit down and review schematics, because he would know if you were breaking rules or not.
Sure.
Which would be a huge head start before you started going and purchasing components.
Absolutely.
My last piece of advice is that GigaVac, GIGAVAC, they donate 2 or 4 contactors for free to each team. I forget how many. So if you just email them and tell them you're an SAE team, they give you contactors, high voltage contactors that you can use as your AIRs. AIRs?
Yeah.
I think it's AIR.
Yeah. Isolation relays.
I think it's 2 free contactors. So if you're only having 1 accumulator housing, that would work, because you could have 1 on each side. But if you're gonna have multiple modules like you were talking about, then you might need to buy more. But they're used in Teslas. They make them out in California, and they work really well for us. So,
Sure. And that would actually, given buying a pre-built part for that would give quite a bit of peace of mind for at least that kind of,
Oh yeah, don't make your own contactors.
yeah,
No,
that sounds.
Live to hide your contactors. That's a huge safety thing. I work with contactors at work now.
Oh, cool.
But just buy contactors. Don't even try to make them. So just go take it back, and even if you don't need them and you just want to order them, get two in and play around with them to see how they open and close, which
Yeah.
way's positive, which way's negative. It's a really cool lab experience as well.
Sure. And what are what are some other how many major microcontroller? What are some of the major kind of control points to keep in mind? That you might have run into trouble with, or that.
So for our year, our controller, we used a Curtis controller. Now, it's unfortunately not compatible with your MRACs, but they already had functions like ready to drive sound built in and a lot of that functionality, but ready to drive sound's a big one. Your controller probably has the throttle as a direct input, so you don't need an extra circuit for that because you're not a hybrid car. You don't need to control engine throttle.
What
I'm trying to think.
what did so I've had some experience with low-level communications, or like serial communications for that you see with embedded systems, but I saw some kind of interesting. So there's CAN for vehicle or just porting data out for the entire vehicle over one single bus. And there was FlexRay, which I read was a little bit more sophisticated than CAN.
Yeah.
Is it?
CAN is really easy, and Orion is solely based on CAN, so all your signals come in as CAN. And it made it really easy to communicate with all parts of the car. So most teams use CAN.
Sure.
So if you can kind of master that and get a dongle, and most cars in industry use CAN as well. So
Real world.
not just read your any direction, weigh your pros and cons, but the evidence shows CAN is a good option.
Cool, cool.
We might be able to pitch ourselves as far as tricking one of the electrical engineering professors to let us pitch.
Yeah, exactly.
In his sophomore class.
So actually, I had a couple. Well, I guess I had one big question, and we had actually talked about this, Mara, about the motor controller being water cooled. That's currently what we have right now. Is the motor controller that we have is water cooled?
Yes.
Yeah. So obviously, that would require us to have a whole system that would, need to have this whole water cooling. So as far as maybe looking for a motor controller that isn't water cooled, that is air cooled, I know we said that it was possible, but as far as functionality, is there anything specific that we should look for in that sense?
So the Reinhardt controller is not water cooled, and most teams use it with the MRACs.
Got it.
A very large amount of teams use it with the MRACs. So there's a lot of support in forums out there, and it is not water cooled. It actually comes in an aluminum case. So instead of having water cool, it's a heat sink.
That's right. I remember talking about that now. Yeah.
So Reinhardt controllers, and the MRACs and the Reinhardt pair really well together. There is some troubles controlling it that I saw some teams have at, I guess the initial calibration is what I'll say some teams had trouble with. But they also had an engine to deal with. So most teams get that working. They never have an overheating issue. It's water sealed tight, so you don't have to put it in its separate enclosure. You just have to isolate it from the frame with rubber mounts or something, so that you don't have high voltage exposed to chassis ground. But other than that, I mean, the Reinhardt's I've never heard of BAMO car, but I'm sure other teams have used it if you found it in your research. But Reinhardt was the one I knew of.
Sure.
Okay, cool.
We're not married to anything.
Yeah. Just more options out there. Because I know making a whole water-cooled system would definitely probably work better because of the heat of Lincoln. I know we talked about that, but it'd definitely be a lot easier to not have to make a system like that, especially for a first-year team.
Right. I think somebody said it earlier, you're a first-year team, you're designing twice as big as needed just to get a car on the ground. So
yeah, exactly.
If you're going with that direction as your team and you just want to pass inspection to get out onto the track, doing water cooling is a good choice.
Right.
And
Okay.
That's your true reasoning for doing it. That's not going to really hurt you if you have sound engineering judgment to go along with it.
Okay. Cool. Is that it? I think so. Yeah. All right, cool. So I guess our last one to wrap it up would be the drivetrain. Our drivetrain lead isn't here, so I'm just going to be going over his slides. And I have been following their process, so I should know a good amount. about, or be able to answer a good amount of questions. So let me go ahead and share my screen real quick. So, here we go. Alrighty.
Or we can go through electronics again.
Yeah, you're really passionate about that, aren't you? Oh, here we go.
Oh, it's the combined.
Wait, combine? No, hold on.
What were you looking for?
I'm looking for drivetrain. Why is it not
You're gonna
here?
have to go up into the parent folder. You're not on the combined.
Oh, I'm in electronics. Get oop.
So
here we go.
Initial design review, yeah. You're good.
Whoops, wrong one. Got it. All right.
Yeah, you're good.
Okay, cool. Yeah, so this would be our drivetrain. Obviously, we went over a lot of stuff in electronics, but we'll probably be okay with overlapping. So obviously, the overall goal of it is to make it move and pass tech inspection, obviously. That is the number one goal of the team this year. And then we also want to be able to use the motor to the fullest capacity while staying within the competition regulations. So staying within that 80 kilowatt power zone would definitely be a big one. We were thinking of possibly just capping the motor capacity below 80 kilowatts just so that there's also less forces going through our drivetrain and possibly our entire car, just to ensure that things maybe last longer, or possibly are just able to work better off of smaller loads. And then we also want to make sure that we're working with our other sub-teams to ensure the most efficient layout of our car. So yeah, for our motor, as we mentioned, we're planning to use the MRAX 228, and compared to the 208 model, there's an increase in continuous power with a small increase to weight, although the weight isn't even that much. I think it's like 9.5 kilograms, so really small and powerful. And of course, many other teams use this motor, so we'd be able to get a lot of advice from other teams, as well as I think we found some forums on the motor as well. So there's definitely resources out there for us to get help. And then MRAX also offers a lot of information as well, such as statics and tables and given data. And actually, we'll show a bit later that we do have a CAD version of it as well. So our plan is to use the liquid-cooled motor right now because we've chosen a liquid-cooled motor controller. Obviously, if we use a air-cooled motor controller, we'll switch to the air-cooled motor, and then we'll just do some fancy air duct, well, not necessarily fancy, but we'll make some air ducts so that we can pass air to the motor and the motor controller to make sure that everything is cooled appropriately. But if we were to go with the water-cooled, we would definitely make sure that we have an appropriate system that will cool it effectively and definitely be watertight because water and electronics do not mix well. And so yeah, we'll keep the motor cooled and boost efficiency, but you know, being the first competition, we do want something that runs and pass tech inspection. So that's definitely why we're on the verge of that and what exactly we want to do. Personally, I'm kind of leaning towards the air cooled just because I know that's one less system that we actually have to do. So as far as how much the whole motor would cost, we've estimated around $4,000 after our conversion from euros, and it ships from Slovenia. And after, or if we were to switch to the air-cooled, it would probably drop a couple $100 because the water-cooled one is a special type of motor. And then as far as our 3D model, as I mentioned earlier, we started putting one in Creo. We like downloaded one off of a PDF and then we're somehow able to convert it to a 3D model. So that worked out pretty well, and so that'll also come in very handy for when we want to implement that into our chassis and doing all those calculations as well. I think there's one more. Yeah, so this will be the schematic of the motor, as I'm sure you've seen a couple of times as well. And that's that. Yeah, so then,
Okay, so,
yeah, go ahead.
go ahead, no, you got better.
Okay, so as far as the other drivetrain components, obviously there's a lot missing here. We were definitely going to go with chain drive. When we were looking into rear axle stuff, we were looking into differentials, and we were having some trouble trying to find a chain-driven differential, but we're still trying to look into that, and we're not exactly sure if we're going to stick with one model or another. And then, do you know more about that, Walker?
I think we might have found some differential. I can't remember what
Yeah.
it's called or anything.
I remember like a picture off the top of my head. I don't remember the name though. But yeah, so chain driven, and then also actually when we were at Iowa State, they had an adjuster for their was there a change oven?
I do have a picture.
Yeah, so they had an adjustable thing so that you could tense and loosen the chain as appropriate onto their rear axle, and then they also had a differential as well. So we were planning on emulating some sort of design like that as well, and then we were just gonna probably implement a simple drive shaft onto the wheels and then into the uprights as well. So keeping it simple, definitely, and yeah, that's kind of the main components of the drivetrain itself. So yeah, go ahead. I think you had some questions. Oh, cute dog.
Okay. Yeah, so, for the motor mount that comes with end rack, don't buy it, don't use it, use it, put it in a CAD model.
Okay.
It's absolute garbage. Make your own motor mount.
Okay.
Word to the wise. The RIT team used it this year, and it ended up torquing on them so bad when they applied a load.
Oh, wow.
It was terrible. It's actually designed to be a plane propeller, because that's what this motor was originally designed for.
Really?
So word to the wise, don't use motor mount. Yep. So for the differential, typically you can bolt on your own sprocket so that you can create your gear ratio. So just look for one that has a bolt pattern, and then you can buy just a generic sprocket off the master and make your own bolt pattern to match the diff.
Gotcha.
That's what a lot of people do. So if you find one that's even just has a bolt pattern, just know that you can put your own sprocket on it with your own gear ratio of choice. And then chain tensioner was my next question, if you had a plan for that. So a lot of teams do a lot of different things, but it's definitely necessary because your chain will stretch out through the use of the car.
Mm-hmm.
So, other than that, I think a lot of the differential in the drivetrain is going to depend on what you decide for your max torque output and determining what you want your specs for your car to be. It looks like you have rims picked out, so you should be able to know the circumference of your tires and start to do speed calculations, and then derive a torque that you want to achieve, which directs right back into the amperage that you need in your batteries. So that's always a good calculation to do, to go from the contact patch all the way back to the accumulator to an amperage and C rate you need to provide that to the motor to get the torque you need. So,
yeah, we were planning on using 13-inch wheels.
Okay, perfect. So 13-inch wheels with the tires, typically like a 22-inch circumference, depending on give or take for rain and dry tires.
Okay, that's good to know.
And then you can do your calculations and do the ratio back to the motor
Cool.
to help figure out what speed you want to go.
Right. As far as minimum speed, I know that in competition you're supposed to be like 40%, no more than 40% above what the fastest time is. Is that really something to worry about? Because I know I've seen when I was at competition that cars will really slow down a lot so that they make sure that they finish.
I've never heard of that rule. I would say just do whatever you think you need to do to complete the race. If you want to spec out your car for drag and you want to go really fast for a short period of time versus you want to do well in endurance, that's up to you. That's up to your decision, because you can't be good at both. So it's got to be a balance game.
Gotcha. Okay. Did you guys have anything to add? No? Okay, cool. Yeah, so I guess that was really the overview of drivetrain. If our lead was here, he'd probably be able to go into a bit more detail, but this is really the biggest parts that are going on right now. So definitely trying to put our designs in CAD and then hopefully implement that into the chassis so that we get the correct mounting points and just the specs on what size chain we even need.
Great. I thought this was great. You've done a very good overview. You guys have a really good head start.
Fantastic. Yeah, so did we miss anything? No, I think we got it all. Wow, okay. Hey, that's great. So yeah, do you have any other like quick questions or things that you thought of while we were going through this?
Did you ever look into Windchill or your CAD sharing system?
No, I did not. Yeah, but I definitely do remember going over that. Yeah.
Okay.
We'll definitely look into that. Yeah, so I guess.
Can we talk about the CAD sharing after Windshare for sure?
Yeah, definitely. Yeah. So for you guys too, the Windchill is like a CAD sharing system, and I know we were going to try and get like a file on the Iowa servers, but this could also be a really easy way to make sure that all of our CAD files are shared and so everybody's on the same page.
How do you spell it?
Just Windchill.
Windchill.
Yeah.
Chill.
Like CAD, I think it's specifically for Creo.
It is, yep.
Yeah.
Windchill. Okay.
Yeah. Yeah, so there you
Didn't know
go.
if it was a play on words.
They usually can give licenses out. The only reason I said that is because one of the biggest mistakes teams make is that they don't have CAD that's shareable between team members and then things don't integrate right. So
Right.
if you get that set up first, I promise you'll be more successful and save a lot of time.
Okay. We will definitely get on that.
Does Autodesk have a good solution
Other
that you know offhand?
If you want to set up like a monthly review just to go over updates or ask questions along the way, I'd be open to that, and we can bring in special guests if you want to review circuits more heavily one night or project management a different night.
Yeah, that would be absolutely phenomenal. Yeah, that would be fantastic. I definitely would want to set something up like that.
You can give my phone number to anyone if the chapter your suspension or electronics just has a quick question they want to run by me. I talk to my rules friend on a regular basis, so if you have just quick electrical questions that you want to run by me, just shoot them over. Don't hesitate to contact me.
Okay, awesome.
Try
Thank
to
you.
respond quickly. And the sooner you ask, the sooner you get the question out of the way, the sooner you can move on in the design.
Right.
So time is of the essence. Don't be afraid to reach out.
Awesome. Thank you so much for that. I really appreciate that. I did have one question. So now I guess you've seen, and I guess really this was almost the first time for me to see all the teams in one go of what they're doing and how everything is going along. So as far as your opinion, how well do you think all the teams are communicating and working together?
Well, I thought it was really great that the chassis designer is anticipating that you'll need twice the space.
Right.
He's really thinking big picture, how much space you need. I always, excuse my language, but the oh shit box is the electronics box where all the stuff goes that you forget about until you start to develop and realize you need contactors and relays.
Right.
Oh, an extra fuse. Where do I put this? So the fact that he's thinking about that is excellent. I do think drivetrain and electrical need to be hand in hand at this point of the progress, since the torque and the gear ratio is really directly back to the amperage, which controls the whole design of the electronic system. So the communication between those two teams is essential right now.
Definitely.
In the design process. Similarly, suspension and vehicle dynamics with the chassis, that could be an area that needs to talk a little bit so that they can make sure that their mounting points, because that's a huge part of suspension geometry, are lining up to what he has designed in his chassis model.
Yep.
Just so that the nodes line up and that you don't have weird forces in the middle of the bar, because that can induce a bend moment.
Yep.
So some things we didn't talk about. Steering system is going to be a huge one. Ergonomics, I know it sounds silly. He said he was designing the Percy, but physically making a CAD model of Percy and putting him into the model is a whole different story. So I'd advise that'd be a good thing to do and see if the person can fit at a comfortable angle.
Gotcha.
You have to be able to handle the thing.
Right.
I'm trying to think what else.
Yeah, I mean, as far as ergonomics, we did have one of the biggest people that we thought could drive, and we just took like the broad measurements of like shoulder height and like torso height, stuff like that, to base it off the chassis.
Put it in CAD, see if it fits.
Yeah,
It's
okay.
the best time to do it now. We made a PVC model of our frame before we built it, just
Right,
to ensure
okay.
that it looked right in 3D.
So is that cost effective? Like, what would you make that? Well, I guess, because what's the diameter of the tube? 3/4 inch? So would you just get like 3/4 inch PVC and just kind of get some 90-degree connectors and put together? Okay. Yeah.
We'll just use duct tape. We just got a bunch of
Oh, duct
PVC
tape.
we
Yeah,
can
it's even better.
do, and then you duct tape, and because it doesn't need to last more than a few hours.
Right.
Just so everyone can sit in it, make sure it's what you want. If you have components laying around, you can see if it fits in packages where you need it to be.
Yeah,
It's always a good thing to do before you start buying tubes and
definitely.
putting them together.
Just out of curiosity, do you have any idea how much that cost? If you don't, that's totally
Oh.
fine. I was just curious.
Honestly, probably less than $30
Oh.
for PVC.
Okay, yeah, then we'll totally do that. Yeah.
It's not bad at all.
Yeah.
Supporting members, if they're not critical, right? You just need to do kind of the outline.
Right.
But it helps picture it. You
Gotcha.
can do it out of like cardboard wrapping paper, like.
Oh, yeah, okay.
too.
Totally. Yeah, that's a good idea.
Thing with the tubes.
Mm-hmm.
Crafty. For suspension, for some reason suspension never lines up. So I advise to make it always in cardboard, your A-arms, as a template to make sure that's really what you want and it fits to the frame before you actually start welding your A-arms to your spherical bearing housings. Let's see. Some other like small details will come across along the way, but for now, I think the only major subgroup that should probably start being incorporated is steering.
Okay.
Because it'll have a big impact on suspension and your upbeat design.
Definitely will.
And then you can worry about other details later.
Yeah, definitely. Okay, fantastic. Wow, awesome. Yeah, I have a lot of pages of stuff now.
I think we might want to allocate over existing members and from systems over to
So if
steering.
you want to do a meeting next month, we can do that and just schedule it now.
Yeah, so, well, I don't know, what, a month from today, so what would that be, June? Oh, wait, that might be, oh, no. Yeah, that would be right after Lincoln. Is that possible?
Potentially.
Sure, I'll be at Lincoln the whole week, so if you're there and you want to do it, we can do it while we're there, or we can do it right when we get back.
I don't know, if we were to, well, who's coming? You,
Yeah.
Greg, Ryan, me.
I can make it towards so I have class on Friday until noon.
Yes, you'd be the weekend.
And so I'd be the weekend.
I don't know, if we were to do it in person, how would that work? Would we just, like, after the day, then go back in, like, a meeting room at a hotel? Okay. Yeah, I guess that could work.
We can go to like a
business
Starbucks or something.
Oh, yeah. You know what, yeah, why don't we give that a shot? So, I don't know, what would be the least busiest day? Probably one of the beginning days would probably be least busiest.
Any if it's done.
Let me look at my recruiting schedule, and then I will let you know which
Okay.
day is my least busy and see if it aligns with you.
Yeah, well, I mean, we don't really have a schedule. We don't have a car there, so that definitely gives a lot of flexibility for us. So, yeah, whatever works with you, I think that would be fantastic.
And if you're a junior, bring your resume if you want to work at GM.
Oh, okay, yeah. Hey, did you guys hear that? Okay, yeah, well, definitely. We'll definitely put the word out to that. Thank you very much for that.
Yes. Okay, so I owe you my recruiting schedule because I'd like to meet everyone in person. I think that'd be excellent.
Okay.
And the suspension website and Polaris contact.
Okay.
Am I missing any other action items?
I don't. Wow, I've got a lot of stuff here. I don't think so. Yeah,
Okay.
those three
I
things.
can send you late tonight or late tomorrow. We can work.
Yeah, no problem. Whenever you can. Okay.
Anything else for me?
I think you've been an absolutely tremendous help. Thank you a trillion times over for everything that you've done. I don't think half this would be possible without your assistance and guidance. So thank you so much. I really appreciate it.
I look forward to meeting in a month.
Yeah, definitely. I look forward to seeing you at Lincoln as well. Okay, and also thanks to the other people that were listening in too.
Yes, text me. Anyone of you, text me with questions.
Okay, awesome. Definitely will do. All right, thanks again, Mara.
All right.
Have a good night.
Great night.
Bye-bye.